The cross product, there's two ways that we can do it, and in fact there's actually a third, because I don't do it with this. I have with the plus here, okay, because if you're doing this you go minus, ding ding ding, I say plus, and so when I'm doing the J it's A3 B3, because I just keep going around, so go right then left. And Jules, you're looking at me funny, but as soon as we apply this, hopefully you'll see that, oh yeah, it's all good. I had students previous years who loved this formula, wrote it down all the time, they used it. I myself, like Tom, like to use this one because I remember how to do the determinant. It's just the cross doodad, how we go. All right, so let's have a look at number 5. By all means, if you haven't done your homework, once we've finished, go off and do question 1. The purpose of this. What is it giving us? Yes, Sam. So close. Perpendicular. Yeah. So it basically, if I've got a vector going here and I've got a vector going, my legs went this way and my arms went that way, it's giving us this vector here that is perpendicular to A and it's perpendicular to B. Now, when we later on are finding the equation of planes, that's going to be really helpful. It gives us what we call the normal vector. So it comes back, we keep using a lot of these things. At the moment, it's just, we're going to use it to help us find the area of a triangle and a parallelogram, and then a 3D one. So up to you if you want to go and have a go at use that formula. What I would suggest is you use both methods and then you see what works for you. Okay. Having said that, I'm not going to go the formula because you can look at it and easily substitute in. I'm just going to try and convince you to do the other thing. So what we do is we look at, and you can remember your determinant from last year, right? But we're going to start by saying the I, the J, the K, and that's a good memory for these are our unit vectors. So I is 1, 0, 0, J is 0, 1, 0, and so on. Okay, and then we just pop these here, so that becomes 2, minus 1, 1, 0, 1, minus 2. And now we would go, I just put my A at the front, so the I, sorry, and it becomes, so that column is now blocked out, and we're looking at the minus 1, 1, 1, minus 2. Okay, this is how I differ from the one that's put in the book, because I stick with plus J, and I'm still now going from this one and going around, if that makes sense. So the J column is blocked out. I write the 1, the minus 2, and then the 2, 0. So your textbook does it the other way. They just go this and this, but then you have to put a minus in. So your call, do what you want, just don't mix them up. I've been doing this for too long. So then K is then 2, 0, minus 1, and 1. And then we simply work out the determinant of a 2 by 2 matrix, and that's just the cross by the cross. So Jules, I don't know if you remember any of did you do any of the stuff from matrices? Oh, you were in matrices, sorry mate. So minus 1 times 2, it's positive 2 minus 1 times 1. Obviously I'm writing these steps in, you could just boom, do it. So then J, again we're doing the cross, so 1 times 0 is 0, minus 2 times 2, so that becomes plus 4. It is so frustrating when you lose a minus somewhere. So concentrate, don't do it while you're talking about, I don't know, the latest Swiftie concert, whatever, just concentrate. And 0 times, we love a good 0 in there. Absolutely love a 0. Okay, so this then allows us, this is 2 take 1, so it's 1i. So this gives us the vector, well actually I'll write it in both ways. That gives us the vector, it's 1i plus 4j plus 2k. Now you can write it in that's the unit vector form, or you can put it as 1, 4, 2. How you can do the cross product on your calculator.
So you go option F2 and then F6. So you do that twice and go to cross P and you exit back out twice. You go to math, yeah. Then this one, and then that. And so the vectors were, sorry, so it was
So someone should be calling them out for him.
2 minus 1.
This is where I get frustrated because I always want to put enter, but you have to use your arrow keys to go down. Everyone remembers this? And Will is just seeing it for the first time, but he's used this maybe before.
Okay, once you've got the first vector, you want to exit out of that and then press the comma. And then do the same thing again with the second vector, so it's 0.
And as our lovely student is popping those in, hopefully when you're seeing that, you could see some of the other things there too. There was angle, there was dot product. I've said it before, I'll say it again. If you're using your calculator to work out the dot product, get out. No, I'm kidding, but you shouldn't be. All right, angle, absolutely get it to check. So again, this is another spot where use technology. If it asks you to do it and it doesn't say algebraically, use technology. And, you know, even if it did say algebraically, you've got all your answers, but then check that you haven't done something silly, because this is not a spot where you want to lose marks on. Agreed? Why am I asking you to do this when the calculator can do? Because look down at question 7. They're now asking you to prove that these things work and you haven't got numbers. So obviously, if you can do it nicely with numbers, it becomes then routine to do some of those ones. Now, you hopefully have made your own decision. When you come to this, you can prove this either using the determinant one, or you can do it using the formula. Your call. But you're basically just going to do the left-hand side, you're going to do the right-hand side, and make them equate. Want to try that? So I'll give you a little bit of time. Make sure you can use your thingy by doing the numbers, and then try and have a go. So maybe 7 and 8. And if you look at 8, when it says use the properties, you're going back up here. And those are the properties that you're looking for to apply. If you get stuck, I'm right here. All good? Love the fact that Will's got his book and has got them there so we can see it all. As I said, I will give you the summary of the whole vector stuff, but as we go, it's nice if you just have that. So use the properties of vectors, cross product to simplify. So there have been in the past, there's been some questions that just are as simple as this. But if you do not have your properties, then you're stuffed. So I think everyone could go, yeah, well, A cross A plus A cross B. Do we agree? But then, what is, A cross A is 0, because you're thinking you've got the A, what's a vector that is? Perpendicular to the it's just 0, right? So from this one up here, so that then becomes it's A cross B, and it's those simple things. So it's just getting you to play around with those properties. Is that nice enough? Notice that when we've got ones like this, so C, it's sort of like you're expanding normally, except you put that cross there, and it doesn't necessarily mean times, it's a cross product, not a multiply. Quite simple if you're looking at the properties, but if you haven't got those there, you're not prepared, right? In my day, we didn't have a note sheet, you just had to know these. So have them handy. Mess around with them. You can see, obviously, B and D I didn't do, but you can see those. Yeah. Okay. Now, Will, you're on again, because I'm going to jump the gun just a tad. As we said, you can look at the examples here. Find all vectors perpendicular to these. Well, hello, we do exactly what we were doing before, but now we can just say it's times by scalar. And it can't be 0, because then that just disqualifies everything. So you make sure if that is a question, you do have to qualify that. Non-zero, I just put comma k does not equal 0. Up to you. So same thing, do we have to do these at all? I don't think so. I think we're quite happy to get the cross product. Just be aware that that is another type of question. All good? So, find all vectors perpendicular to, hence find two vectors of length 5 units. How would we find something that is a particular length? Unit vector, okay? So we're going to, do you remember unit vector? Too good. Find the length times by 1 over and then times by 5. Okay, we're going to come back to this stuff a little bit later on when we talk about planes in the next bit, so we don't have to worry too much there. Oops, come on. Oh, little bits in green are the next thing that you need to write down, and you'll see when you do the first review set of chapter 6, this one's rather handy. We're going to use an adaptation of that in a minute to find the area of a triangle. And we just talked about this a little bit before, that when we do the cross product and equals 0 and neither one of those vectors was 0, then that means the two vectors are actually parallel. So handy little things just to have there. You'll see in a minute where that's going. So the rest of chapter 5, there's a little bit of vector geometry, but we're going to save that for a little bit later. We just want to get straight into the algebra type stuff. So we're on to, and again, some of this will be using your calculator. But knowing, if it says we've got a triangle defining these vectors, notice the vectors have to go outwards. So they're going out and out. You can't see me moving, so out, out. And this is our formula for area of that triangle. Take away that half, so don't times it by half, and we get the area of a parallelogram. If it tells me that it's got a depth, then I can even find the volume. What is that called? A paralleloped? God knows. Okay, so handy things to write down. And where it comes up a bit is, what do you notice? Instead of giving you the vectors, they're asking you to find the area, which would be the cross product using that formula, but they've given you the points. So that's just a little reminder, how are we going to find vectors A and B? So if we've got 3 points, and remember they're in space, so A, B, C, you could do, if you wanted to start with the A, then you would have to go, change colour, you would have to go AB and AC. Clearly, if you just wanted to mix things up a bit, if you went with BA and BC, you will get the same answer. Okay, but please do not go BA and CB. That will get you the wrong answer. Very simple. Just in a parallelogram. Didn't know this, so draw the diagram. And then we said that BA has to equal to CD and equate. In 2D vector land, to find the equation of a line, we need the slope and a point. And it's basically the same thing in 3D vector land, except our slope is our direction vector. And they'll tell you this is our vector, blah, 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 blah. And then we also just need a point. The crazy thing is that there are actually 3 ways to represent this vector form, right? So the first one is parametric. Well, actually, that'd be the second one. And we've also got the Cartesian equation. And this is our vector equation. Okay, so it starts off really easily and you've got a beautiful example there that we can have a look at. So we take out, here's our point, boom, boom, it goes there. Plus, then we've got our direction vector. It even tells you that it has in this direction, so it's giving you the heads up. Instead of saying the slope, it says the direction. Boom, boom, and times it by a parameter. Quite often it's t, but then when we do it, we will say t for time. So we try and use lambda. They will use r. They can use s, whatever. And of course, we tack it off with it's real. To get it then from this form to parametric, you can see all they've done is just x equals 1 plus 4 lambda and y equals minus 2 plus 5 lambda. Very simple. So it's nothing extraordinary. Do you have to write all 3 forms every time? No. They'll ask you, do it in this one, do it in that one. I think probably at the beginning they'll ask you to do all 3 just to get jiggy with. Okay, can you see here, this is x minus your point, and you divide it by the value of your unit vector. The only thing to watch out there is sometimes, like this, they might actually give you the equation and you have to go back and state the direction vector or state the point. And so just be careful with this. Sometimes they might actually rewrite this as 3 take z over 6. So if they wrote 3 take z, your z is now minus. Don't be fooled to think that your vector would then be 4, 5, 6. You'd have to put the minus downstairs. Does that make sense? Wait. So again, they go over and over stuff here. I don't think you need to do it all with just 2D. We're going to start with question 4. Huzzah! Because all that stuff is similar to, that. So question 4, let's go onwards. What's your life looking like at the moment? We know we've got it tomorrow, so can we start by just making sure we're happy with... Do as much as 4 as you want. You might get stuck when they're talking about parallel to a plane. And then 5, find the vector equation of a line which passes through. So what's happening? What do we need to find the equation of a line? Direction vector and a point. Now, points galore, but you haven't got the direction vector. Well, that's fine. How can we find the vector AB? That's B minus A. Okay? So how about just finish those area ones and 4 and 5? Is that okay? Because it's straight tomorrow.